So we're going to do this general introduction to Python. We'll do the live coding the last two lectures. And then next Tuesday, for the group project, we're going to have a discussion about development practices. Okay, so we're going to look into getting you to think about what are the things that you need to think about, not just the technical coding aspects, but the things around the development of your code as a group assignment. To make it easier for you to develop that code as a collaborative group. So, yes, it's not just about sort of knowing the technicalities of the languages, but also how you're going to work, what kind of infrastructure you're going to use. Has anyone here heard of something called version control or revision control? Okay, like GitHub. Anyone use GitHub? So, can I have a quick show of hands? Anyone who uses any kind of revision control system or version control? Great, that's really good. Everyone would expect to see that. That's really good. So we'll have a discussion about version control, a few other little questions about how to write good code on next Tuesday. And then also there'll be some Python Lab help lessons as well. So the first two are going to be this Thursday between 9 and 10. Although if I don't get through all the live coding today, we'll probably spill a bit into this Thursday. And also the week after, but also I'm going to be sorting out some dates on my calendar where I'll be available and you can just pop up to the Zephyr Labs and you can ask any questions you like about Python if you run into any issues or have any kinds of questions at all. So I'll post to the group so I want my availability for that. So what we're going to do for this lecture is we're going to look at what is Python, where it's come from, the kind of drivers and motivators behind it. We're also going to look at who uses it, to what extent it's actually being used out there at the moment. And also we'll see what the kinds of things you can do with Python, the ways in which it's being used. So let's start with what is Python? Would anyone like to take a guess for where the name Python came from? Bear in mind, you know, the guy who wrote this initially was a geek, okay, he liked coding. So any ideas? Does anyone know?
Monty Python?
Yes. Not much from else who thought that as well. So the guy who wrote it, initially started writing it back in the late 80s, claimed that he chose Python simply because I was in a slightly irreverent mood. He just decided to name it Python because he liked Monty Python. That seems to be what he'd been watching at the time. That's how a lot of these things get named, as it turns out. So, what is it? What is Python as a language? Well, it's very much a general purpose language. It's very high level. You can do, as we'll see later, a tremendous amount. If you can think it, you can probably do it in Python. It's also free, it's open source, it has a huge backing, community backing and support. So if you do happen to run into any problems, pretty much if you go to like Stack Overflow or any other number of community forums, you can almost certainly get around to your question if you do have a technical problem with Python. Huge community support, so that's very important. It's quite actually a fun to use language. This is what people say, it's fun to use. And I have to say, when you compare to using it to other languages, it does tend to be a little easier to learn. A lot easier, I'd say, actually. Has anyone here used Perl? Quick show of hands. Did anyone find the learning curve a little steep with Perl? No? Oh, that's interesting. Well, in this case, you'll find this a breeze then. It has remarkable power for what's the simplicity of the language. So you can write very high level statements that enable you to do a tremendous amount of things and write very simply. And this is actually one of the very, very key driving forces behind the development of the Python language. You can do a lot with it with very clear syntax, and there's usually only one way to do something. If you pick a language like Perl, for example, there's usually like 100 ways to do something, maybe 10 or 20 ways to do something or something. With Python, there's generally only one way to do it. This actually has big advantages, as we'll see later. It has a massive standard library, so it means that you can do all kinds of things with it. You can do user interface design with it. You can do pretty much anything you want with it. It's very easy to bring in sort of libraries that do transfer stuff, such as number processing with NumPy or scientific processing of data with SciPy, for example. A couple of examples. You can do a lot with it. So if you think you need some support in the language to do something specialised, there's almost probably a language. There's almost probably a library out there that will actually help you to do what you need to do. functional programming in Python if you really want. And there's also something called aspect-oriented as well, aspect-oriented design. So this enables you in Python to do not just the actual code of the functions of what you're actually doing, but it also means you can take into account cross-cutting concerns, like how to manage logging and so on and so forth, and you can define these aspects outside of your main code base. So it means that your main code base doesn't get cluttered with logging statements all the time. It means that you can just say, I just want these aspects to be logged in this way separately. That doesn't interfere with the clarity of your main program, which is quite nice. So you obviously will have your own styles and preferences for how you like to code things. So it's pretty flexible that way. And one thing you should probably do when you're deciding as a group is which kind of paradigm you should be coding in Python, so that others can understand what it is you've done. So, what sort of language is it? Well, there's languages on the compiled side of programming languages, also interpreted languages. So let's have a look at a few of those. So for a start, beginning, you have a compiled language, which is explicitly compiled to machine code. So things like C, C++, and Fortran. You write the code, you run it through a compiler, you get some machine code, and you can run that on your target platform. No problem there. And then further slightly along this scale, you have languages like Java and C#. And these are explicitly compiled to bytecode, so you have to compile those into an intermediate format, which can then run on something like the Java virtual machine or the C# common language runtime. So that's kind of an intermediate form of compilation. And then at the far end, you've got interpreted. These are things like Bash and Perl, where every statement, as it's encountered in your program as you're running it, is actually interpreted and run on a per statement basis. So that's the opposite end of the spectrum, and perhaps not surprisingly, there's Python that's kind of sat in the middle. So what Python does is it implicitly compiles your program to bytecode as it's running. So it does this in the background. You don't even need to know that it's doing it, which is actually quite nice. It kind of gives you the best features of a purely interpreted language with the debugging aspects and the clarity of what happens when things go bad. If your program crashes, you tend to get some quite helpful error messages. But it also gives you some of the performance of the more compiled languages as well, which is quite nice. And there's even ways to make Python even faster in terms of execution using things like just-in-time compilers, for example, that compile the thing into machine code as it's actually running. And that can give you some significant performance advantages. So Python then has this thing behind it, this approach to how it's designed, some principles that influence how it's been designed. And it's got some rather sort of tacit aphorisms, such as beautiful is better than ugly. Okay, so writing something beautiful and elegant is actually something they advocate you should do, and the language has been designed to support that. It's also the case that explicit is better than implicit. So instead of writing things like in C, for example, you might write lots of things using pointers. You have to kind of work out what's going on with the pointers. In Python, whenever you write something, you're generally writing it to say this is exactly what it's going to do in Python. So it means that someone who's reading your code, someone else, especially in group projects, you might find this, when someone else is reading what you've written, it's generally very clear what's actually going on, because everything is explicitly put there. Simple is generally better than complex, so you'll find that when you're writing Python, it kind of tends towards a simple kind of design of a program, which is quite nice. There's some really good reasons why these are good things, which we'll come to in a minute. Complex is better than complicated. It took me a while to understand this one. So if something is complex, it doesn't need to be complicated. You can write something that's complex using a lot of simple statements, but you can write something that's simple in a complicated way, and that's something that obviously makes it harder to understand. So what they say is it needs to be complex, it doesn't necessarily need to be complicated. And we'll see some advantages of that later. Flat is better than nested, so there's a lot of languages out there that kind of incline you towards using lots of nested statements. And this means that you end up with a kind of indentation sort of following like this, and makes your code a little difficult to understand for yourself later on or for someone else who's trying to read it. And so, generally in Python you'll find that programs naturally tend to follow a more flat design, so it's easier to follow. Also, readability counts. as we see in group projects, if someone else is reading your code, or even if it's yourself going back to the same code you've written, like 4 weeks ago or something, you'll find that generally in Python it's easier to understand what it is that's been written. And this is a real core tenet of Python. There should be one and only one obvious way to do it. So like I said, in Perl, for example, there are like 20 ways to do any one thing, perhaps even 100 in some cases. And that means that if you have one person writing a Perl program and another person writing exactly the same program, often what happens is they end up with 2 completely separate programs that look very, very, very different. In Python, they'll generally tend towards looking the same. So those are some sort of design principles, but there's also some core reasons why learning and using Python is good. It is generally considered to be a very good language for novices and experts. I remember when I first saw Python, I think it was back in '97, I thought, what the hell is this language? Yet another language? But I have to say, even reading the most complicated Python programs tended to be a lot easier. And it didn't take me particularly long length of time to get to grips with it. And hopefully you'll find the same. For this reason, it means that it's generally, I would certainly say this, it's certainly a solid language for collaboration. As you said, there are many ways in which you can write different programs using different languages, but in Python, usually the way to write it is generally sort of, it just comes out one way, and it's quite a simple language, and yet it's very powerful. And this means that when you're sharing Python code with other people, it's generally quite easy to understand. And it's got a very simple yet powerful syntax. It's generally quite easy to learn. You don't have to do any compilation, as we've said, and as we've also said, you can do an awful lot with it. And so, summing up Python then, in one simple hello world statement, this really does sum up what Python is trying to do. So in C++, you just want to say hello world. Okay? And one way of doing that, and there's probably others, is you do this. You have to include a library. You then have to put something, you put something into a main function, you then say hello world, and then you put that into cout, and then yeah, so that's just saying hello world. In Python you just say, can I just print hello world please, and that's it, you're done. So this kind of ethos follows throughout the whole of Python. It's generally quite straightforward in that way. So there's the two versions of Python that are out there that are commonly being used at the moment. There's Python 2 and Python 3. So a lot of questions we get asked are, should I be using Python 2? Should I be using Python 3? It's a good question. It's kind of reaching a tipping point in terms of who's using Python 2 and who's using Python 3. Python 3 is the new up-and-coming one. It's generally considered probably to be the future of Python. It's almost certainly going to come to the mainstream soon, I would say. And so at the moment there's kind of a tipping point as to which kind of version of Python you prefer to use. So Python 2 and 3, there's some subtle differences between the two. Python 3 gives you a lot more features. Having said that, Python 2.7 is currently probably the one that's most used out there at the moment, but it's starting to tip now towards Python 3. So generally the development community is moving over to Python 3 and advocating that others just get started with Python 3. So Python 2.7 is still very much a valid choice. We do have one constraint for the coursework. The Google App Engine, which you'll be using as part of your coursework, only supports version 2.7 at the moment in production. They do have a version that supports Python 3, but it's only in beta, and we strongly advise you not to use that version. So using 2.7, that's the way to go. So of course, feel free to ask questions. Am I going too fast at the moment? Is this okay so far? Okay, just let me know if I'm going too fast. Right, so we've seen that in Python there should only be one way to do something, and also readability counts, two very important aspects. Why are these so important? So while I was working a while ago, let me see how long ago was that? 12 years ago, I was involved in a project with lots of other collaborators, and we were writing a system that basically enabled you to submit jobs for a distributed computing cluster. So a cluster of machines, and in front of that was like this service. And the service enables you to accept jobs, send jobs to it, and then it will distribute those jobs automatically over a number of machines. Okay. And a lot of that was written in Perl. Now, we had some collaborators at Southampton and some in Manchester, and the problem was that every time we were writing programs in Perl from our side, we were finding that those in Manchester were having difficulty understanding them, and vice versa to some extent. And the largest problem with that, as we said, is that Perl, there's hundreds of different ways to do that. It's an incredibly powerful language. It is very, very successful. It underpins a lot of what goes on the internet at the moment, for example. In fact, I did my PhD thesis implemented that in Perl as well, for example. So it kind of lends itself to being a little difficult to collaborate with unless you absolutely pin down how you're going to decode in Perl using a style guide that you agree on in terms of how you write Perl. So this does mean you can run into problems when you're sharing code and you're trying to explain how it works for other people. And we even had people in our lab using Perl, and we all each had our own different ways of doing things, and we had to converge. It's quite a painful process to get our styles to converge in one way of doing Perl. So there was this interesting comparative study between Perl and a language called Randomo, and another language which isn't particularly important here. And the interesting thing was that Randomo's syntax was randomly generated. So the syntax was absolutely randomly generated, okay? And they compared it with Perl and tried to determine which was the easier language to learn. It was just an interesting thought experiment, which turned into a real experiment. And the question they asked was, which was easier to learn for novices? And something interesting that came out of that was that Perl users were unable to write programs more accurately than those using a language designed by chance, Randomo, which is fascinating. So it just gives you an idea of the complexity of something like Perl. This is actually what Randomo looks like. It's horrific. I actually went through that. It took me about 5 minutes to understand what was going on. But Perl does look a little better than that, but not horrifically much better. But Python generally quite straightforward. So now we're going to have a look at a brief history of Python. So where did it come from? And there's this absolutely brilliant thing that this guy called Michael O'Gallagher called CodeSwarm. And we're going to look at the video in a minute, and it gives you an idea of how something develops over time. In this case, we're looking at Python itself. So it gives you an idea of how things have been coded, its activity over time. So it gives you a history of the commits to a code repository. You show it a code repository, it goes away, and it actually looks and analyses how things have been committed to this repository. So what it's actually giving you is a social view of how the software is being developed. Who's been contributing what, how often they've been contributing. And so as we see the video later, you'll see that developers of files are moving elements, and when they commit a file, it lights up and flies to the developer's name. It also shows you documents that are committed to a repository in blue, and red files represent code. And over time, inactive developers in this video will fade away. Just so you can, you'll see, you'll understand it hopefully when we start it. And the histogram at the bottom is the commits over time, so it gives you an idea of the overall activity. So let's have a look at that. Right, so let's start. So, I'm just going to move this over. Right, okay. I think we're going. Right, okay. So yes, the language was initially developed by a guy called Guido van Rossum in 1991. That's the first time he released it to the public. Okay, right. So he started this in 1989 at the Master Computer Science department at CWI in the Netherlands, and you can see he's developing it here. Is that actually? Can you read that? Is that too dark? Is that a little bit too dark? Right, let's see if I can turn the lights off. Is that a little better?
Yeah.
Yeah. Excellent. Okay, great. Sorry about that, Tom. Okay, so here we can see Guido's committing to the repository, Python repository. He's only the initial developer at this point. There's no other developers. So he publishes the source code to a news group on alt.sources. The first time he's ever published it to anyone. That was in February 91. In January 94, you can see other people starting to contribute to the code base there. Then in January 94, he releases a full version, right, which is version 1.0. And this has functional programming support. The reason it had functional programming support was there was this Lisp hacker that was interested in Python at the time. Bear in mind that there's only about 4 or 5 users of this code at the time. He just happened to miss functional programming in Python, so he just implemented it in Python. He'd been using it before, he didn't have it, so he just implemented it, and it's been supported ever since. And so, in 1995, he actually moves now to somewhere else, the Corporation for National Research Initiatives, and he continues his Python work. And you see more and more people here becoming involved in the development of Python here. So it's now at 1996. And as we come up to December 97, he releases another version of the code, version 1.5, out to the public. And here you can see a couple of people becoming involved with it, more people getting interested in Python and what it's about. You can see here that documentation has now started to become something that's needed. Okay? So before that, it was a very close group of people. They didn't need a great deal of documentation because everyone pretty much knew what was going on. Now it's starting to get to a point where others are interested. They need documentation. So the blue there represents that they needed that to support the new users. So you can see the developer base there starting to grow. And now we've reached, let's see, September 2000. Version 1.6 has been released. It's been released with a new license under Virginia state laws. The Free Software Foundation said that this wasn't actually legal. They had to release it again a couple of months later with a license that was compatible with the GNU license. So now you can see it starting to really take off. There's lots of developers actually contributing stuff to the code base here. Support for it is growing. The user base has exploded. And now, let's see, in May 2002, we have a version, there's another one that's been released, and it's unified Python's types into one class hierarchy. So they've actually done some refactoring of the language so that everything is now unified. It was a bit of a hodgepodge of types and other sorts of data types that you could put into the language, and now it's been unified. So they're starting to clean up the code base quite a lot now because it's starting to gain a lot of users. And you can see the developers here actually getting mental. You can see a lot more. There's also documentation still there being updated as the language is being developed. And then in December 2005, Van Rossum then moves and is hired by Google, where he earns a substantial amount of money. And they've been using it for the Google App Engine, YouTube, their internal development, their infrastructure, their administration, and from that point on, Guido Van Rossum, very well known in the language community, and substantially wealthy. Yes, that's Python for you. So note that the language started just as a pet project. It was Guido's pet project. He just wanted it to scratch an itch. He just didn't like languages that are out there. So he decided to write Python. We just had a play with it once, and he said it was only really something I wanted to do for a couple of weeks in December when all my colleagues were away, just so I could fill some time and just write a language that I liked. And he went away and did it, and since then it's just basically taken over and just become really popular. So who uses Python? How many people use it? How big is the user base? Well, let's have a look. So this was a study that the Software Sustainability Institute did, who I work for. We did a study of all the PhD students at Southampton, those who are actually developing software. And this was in 2014. And you can see that basically Python is pretty much the biggest one there. You'll see there's also MATLAB. Anyone here heard of MATLAB? A few people? Anyone use MATLAB? Okay. All right. So we've actually been supporting a lot of people moving from MATLAB to Python in our group. You can also see that there's SPSS for statistical analysis here. There's obviously Git as well. A lot of people using Git. And this software could be anything. You'll see that there's a lot of researchers using Excel to hold all their data. And quite a lot of what we do is actually help a lot of researchers move from Excel over to Python when Excel becomes a little bit too unwieldy. There's also R there, which is a data domain-specific programming language as well, which is very popular. So Python's starting to gain quite a foothold at Southampton. There's also something called the TOB Programming Community Index as well. This basically counts hits for languages across numbers of search engines. So what's the word on each of these languages? How popular are they in terms of who's talking about them, what's out there on the internet? And you can see that Python's pretty high up here. It's the fifth one. These include search engines like Bing, Yahoo, Google, etc. So it's starting to gain prominence there. You also notice JavaScript there. So this is an even bigger picture of all the languages that are currently being used on GitHub. So all the repositories that have any code in them in GitHub are represented here, and you can see the popularity rank on GitHub by number of projects, all the way up by percentage of projects. No, number of projects along here. This is a popularity rank along here, and then on this axis, this is the popularity rank on Stack Overflow. And you can see that Python, you can't really see it very clearly, but it's right up there. So again, Python becoming quite a language to use these days. And you'll see it beats out things like Visual Basic, Perl, Pascal, still being used, look at that. Standard ML, functional programming language. Crikey, Blitz Basics on there. Yeah. Anyone here use Lua? Yeah, I quite like Lua, that's up there too. Yeah. Great game. And so, quite a popular language. It's got a lot of support. People are talking about it, people are using it. So, what kind of things can you use it for? Okay. So, one of the most surprising things I found out was that anyone here play EVE Online? I played it for a while. No? Oh my god, wow. It's a bit hardcore. It's a massively multiplayer online role-playing game written in Python. I honestly didn't think that Python could be used for something like that. And it handles 21,000 concurrent players, 400,000 subscriptions. It's kind of tailing off, I think, in terms of users overall, but they've written an entire game infrastructure using Python to support that, which is quite impressive. Web services. So Django, those of you that may have come across a web development framework called Django. So lots of web development frameworks out there. They seem to come and go like the wind, some of them. Only a few years ago, Kahana was a web development framework that everyone was using, or a lot of people were using. Now no one uses it because it's not supported. There's a whole load of others. Django's been around for quite a while and that's still quite popular. That's supporting Python. Oh, and the online community forum, Quora, that's also coded in Python too. Loads of applications written in Python. Blender, anyone use Blender? Yeah, I kind of like Blender. Learning curves tremendously steep, but powerful, hey? Done in Python. It's free, it's open source, you can model stuff in it. It's quite cool. Science. It's being used in science a lot, a tremendous amount. I'm going to give just one example here. There's a group that we work with called Jonathan Essex Research Group, and they developed a piece of software called ProtoMS. And that's basically doing energy simulation, free energy simulation. And that's basically it provides a piece of code that you can run these simulations in. And we've been helping support them write a test infrastructure for their code base so they can make sure that the code coming out of it, the results coming out of it, are actually what they expect. So we've been writing a unit test framework for them in Python, or at least extending their existing unit test Python framework. You can also use it for instrument control. There's a standard called VISA, Virtual Instrument Software Architecture, and it enables you to plug in a device over RS-232, USB, Ethernet, GPRC, there's that one, and you can control that using Python, using the VISA standard. And embedded systems too. You can get Python for the Raspberry Pi, obviously. The BBC Microbit, which seems to be something that's gaining popularity now for teaching in schools on Raspberry Pi. There's MicroPython and PyLite, TinyPy, Python 64K. You can put it in a very small, low performance, low memory environment, and it will quite happily run some basic programs in Python for you. Who's heard of the Microbit? Yeah? Few? Okay. One thing I've been asked to remind you is about the group coursework. Okay, so this really can't be stated enough, really. I remember when I did my group coursework and I did my degree here many years ago. We left it too late. It didn't go very well. It's easy to think it's just a coding exercise. I can do that later. It's really not. It's a lot more than that. This is what happens if you leave it too late. It's going to be quite stressful. I advise you to get into your groups and start talking about how you're going to do it, what you're going to do, as soon as possible if you haven't already. That's why you leave it too late. But if you started early, it's a party. It can be a lot of fun. It'll be less stressful and you'll actually get a lot of enjoyment out of it. Yeah, sorry, I used the, is it a Doge thing? Yeah. But yeah, so I would strongly advise you get in your groups and start talking about it and planning what you're going to do. So, what we're going to do at 12 then is something called live coding. I'll give you a quick background on that just before we actually start. So live coding, what's it all about? So there's this initiative called Software Carpentry that's been running since 1998, which was co-founded by a guy called Greg Wilson, who in many circles is generally considered to be one of the best computational teachers, computational skills teachers in the country, in the world actually. And the idea is that what we do in Software Carpentry is we teach computational skills to academic researchers. So instead of teaching this much software engineering to researchers who have just started to develop code, we can't possibly do that. They don't have the time, they don't want to do that, that's fine. What we do is we teach them this much, and this much is something that can help them be quite productive. Just a few things like version control, testing, unit testing, good programming design. And we teach them this small amount that helps them to be much better at developing and writing code. It's done over 500 workshops, 16,000 learners, 450 instructors have been trained today to do software carpentry over the world. If you want to know more, you can go here. We've got some great material, including great material for learning Python. We're putting up some links for that on Friday. And what they do, their core approach is live coding. So instead of giving lectures where you're sat there like you are now, listening to someone go on and on and on about something, and they're talking about a language, and they're saying you can do this in it, and this is how you do it. This is a conceptual overview of variables, or slicing, or how to use a library, and it's all very interesting, but it doesn't give you any practical view on how it's actually done. So what live coding does is I actually stand here and actually go through some material and actually code. And you'll see the code on the screen as I'm actually writing it. And that can give you a little bit of handle on how to approach coding in Python. So we modified it for this course. So what it really is going to be about is a practical tour of what Python is, some of the basics of it. Okay? So those of you that actually are pretty good, consider yourself pretty good Python programmers, probably won't get much out of it. So you're more than welcome not to attend the next two. So it's very much targeted at novices. So we'll be doing things like starting with Python interpreter itself, covering some language basics like variables, loops, if statements, functions, basic modular programming in Python. We're also going to be showing you how to write and run some basic Python scripts as well. And the cool thing here is you can actually, if you have a laptop and you want to code along with me, you can. So I emailed out some setup instructions last week to the group. And if you go there, there'll be a link to downloading Python if you don't have it already. Importantly, of course, make sure that you have Python 2.7 installed. And you're able to use that, not Python 3. The material is going to be in Python 2.7. You can get it for Windows, Linux, and Mac. And you basically get hold of it here. But when you do get hold of it, if you want to join in with your laptop, make sure that you download 2.7. You have to scroll down a little bit in order to get hold of that. So don't go straight to the first link, which is Python 3.5, I think. I'd probably advise that you stick close to your group members as well. So as we're doing live coding, you can kind of help each other if you want to join in. You have a chat about it. And of course, at any time, feel free to ask any questions you like. But unlike in Software Carpentry, we actually provide technical support for those that are actually in the course. We won't be able to do it this time because it's just going to be this long me up here. But even if you're able to just start the Python search and do a few things in it, that's got you started on the other way to learn Python. So unfortunately, yes, I won't be able to give you any technical support, but definitely feel free to ask any general questions about what we'll be learning. Okay, right, so I think the time's nearly up. So, I'm just going to end on this XKCD. This was what was in the tooltip on XKCD, so I kind of liked. I wrote 20 short programs in Python yesterday. It was wonderful. Pearl, I'm leaving you. That's the author of XKCD. Have to say, I'm a great fan of Pearl. I think it's fantastic. But I just moved over to Python myself and started to really like it. Okay, so I think that's it. So I'll see you at something maybe, and we'll do some live coding. Okay, thanks everyone. Any final questions?